Western, how many not-boiled Western, correct? And they were A and B, so we changed them to be 1 and 0. Then, when we created, let's say this is for the apple pie, how many apple pie that actually prefer it and do not prefer it? Again, 0 and 1. But that's not all, because we needed to create for the apple pie for how many Midwesterns, how many not Midwesterns. And when you needed all of, if you look at all of this data in here, what do you see? You see 0 and 1, correct?
Yes.
So how did we go ahead and find that 10 and 5? We counted them.
Yes.
Now, counting them, if it was 15 rows, easy, 20 rows, easy, 100 rows, not easy, but manageable, right?
Yes.
What if it was 500 rows?
Difficult.
1,000,000 rows, 1,000, 10,000? It's not going to be running correctly for us. So way much more easier for us is actually, instead of doing it manually like what we have done in here, to actually just go ahead and do it using the program. Writing a simple command like this, go ahead, make sure that you use the pandas that DP to actually read the file, read that CSV file, write where that file is, and I have the file path in here. I'm going to copy it. Now, you're also going to find that when I have, when I have created or tell the program to actually go ahead and write it, usually I just go ahead with this one. But what if it was, the file was actually saved in a different place? Either I need to change the location of that file where I am actually running this, let's say, this Python file from, and it will be able to read it without any kind of problem, or I need to specify where it is located in there. And you're going to see that the path do not copy it as it is. Yours is actually different from mine. So make sure that it is the correct path. And then if you go ahead and copy the path as it is, let's see, I just want to show you, let's say in here, if I go ahead and copy it, I will copy it in this particular place. You're going to see that it is between backslash and a slash. If you do it like this, the program is going to give you an error because the program does not understand it. Either switch it to backslash for each one, or just simply go ahead and add a second slash to it, and you will be okay to go. Now, once this is done, now I will go ahead and execute it. Now it is executed. Now I will go and make sure that I am actually reading from there. So it will be df dot group by. Make sure that when you go ahead and group whatever that is it that you want to do. Do you want to group the apple pie with the potato salad together, or usually as you want to do it, apple pie Midwest, or sushi Midwest, potato salad Midwest, or Age Midwest, or Age with apple pie? Depending on what you want to go ahead and group, you will need to do it like this. Let's say I'm taking Midwest as my starting point. Go ahead, group Midwest with, let's say, apple pie. And instead of me, also, that's something that you can do. Especially if it was, right now it is not that long, but if it was something that is long, you might want to go ahead and copy it directly. That is also available to you. Close it, close it. Now, depending on what? Depending depending, because you are grouping, depending on what? Depending on the apple pie. So basically, it is going to be on the apple pie dot count. Now, count again, it is a method that I am running with, so it is going to be needing that parenthesis. If I go ahead and execute it, oh, I did not close the parenthesis. Do you see here? I have opened and closed multiple times. There we go. This one. There. Execute, and as you can see, we already have got the count. How long did it take? Not that much, because the computer already computed it for you. Okay, once that is done, I already know how many Midwesterns are, not Midwesterns, it is depending on 0, 1, 0, 1 again. I will get 2 and 8, 3 and 2, and I got all that information. Now, can I go ahead and repeat this particular one for, let's say, potato salad? Sure. All I'm going to do is bring it for, let's say, get that instead of apple pie. Make sure it is for potato salad, and as you can see, right now it is being done for potato salad. Good. The code is already, I'm going to post it on Teams, so you do not need to record it. Okay. Done? Now, once I am done with this, now what if I do want it to be done depending on the age? Now let's say age and Midwestern. Now in here, potato salad and Midwestern, all of them, they are only 0, 1, 0, 1 that I got. But if you look for age, it is different. Now I have got a question for you. How many, let's say 33 do I actually have?
1.
How about 29?
1.
1. So how is it going to go ahead and do the grouping for me? If I go ahead and select the age. Okay. What did I mistype in here? Okay, age. Age is a capital A.
Yeah.
Okay, there we go. What do you see? All of them, depending on this, all of them, they are only repeated once, right? But only one age, that is 38, repeated twice. And that's not all. Also, you're going to see 26 is also repeated twice, but 1 for Midwestern because there is A, 1 for not Midwestern because it is with B. So basically, I do have them different also. Now, what if I do want to get all that information? Okay. Instead of me just copying it, typing it, I will just paste it like this and go with the code with it. Quite easy, right? What do you see? Depending on the age, start with the age. I do have it 0. Go second with the apple pie. That's the second column that we have. Potato salad is the third column, sushi is the fourth, Midwestern is actually the fifth column, that we have. But at the same time, we do have the MW for the Midwestern. Western in there, which is 01. If you remember where we have when the head was 01 in there. And with the data frame, because we do want to have all the information on the data, we are actually just moving with, go ahead, have all of that information in a data frame that we will be able to go ahead and understand, dictated. The age is equal to the age. Apple pie is equal to apple pie. So basically we are not changing anything in there. We are keeping the names as they are. We ended it with the Midwestern, and then make sure that we actually have the head. Then, if I run this command, what do you see? It went ahead. What do you see? First of all, how many records do I actually have? 10. Because I already specified that it is going to be 10. But even though in here I have 15. But here is only 10. And did it change anything in the names? No. Because I made sure the names are equal to each other. Now for 0 and 1, whoever wants it, whoever does not want it, again it is 0 and 1, and that's it. I got all the information displayed in there. Now this is something that we can go ahead and display it like this. Now what if I did want it like instead of 10, you know what I'm going to just get the same information, but this time instead of having it 10, I will have it as 4. Run this one particularly. Now, what do you see?
The first 4 records?
The first 4. In here, the first 10.
Yes.
Did it take, because I ran them one after the other, did it take like the first 10 and then the next 4?
No.
No. Okay. Now, with this, now what if I do wanted to have it like on a plot? How will you be able to see all of this on a plot? Now, if I go ahead with figure, make sure we are creating a figure, AX, that is equal to plot dot, make sure that you are creating a subplot for it, or plots it should be, okay, there we go. Then, select which colors that you want. That is equal to, let's say, A, that is, I'm going to go with blue. I will also, no, blue it does need. You know what, instead of me retyping it, I'll just do it like this. That is going to be B, that is going to be, let's say, red. And closing this particular statement, after that, AX dot. Make sure that it is scattered. DF underscore 1. Make sure that I am actually using the data from the data frame. That is going to get sushi. Okay, then it is going to be, okay, for the age, now C is equal to DF underscore 1. That is going to also make sure that it is the Midwest dot colors. There we go. Now, if I run it as it is, you see, all the information I need, it is already all scattered. Now, anything in here in between? Why it is like all one line? Zero and one, nothing in between. All the information I got is actually only 0 and 1. Okay? What about here? What about there? What is this?
Age.
The age. Correct. Depending on the age. Now, how many do I actually have for this? Is it, how many dots do I actually have?
14. 14.
18?
14.
15. Exactly. 15. When I display the information, what did I display it at? 4 in here, then in here, correct? But when I have created it right from the beginning, how many do I actually have? I have 50. So when it went ahead, I'll actually have everything displayed. It displayed it to me as 50. Now, does this mean that this is for sushi, but what if I go ahead with apple pie or potato salad? Is it going to change for the data? Or no? Is it the same? Let's try it.
It's going to.
This one here. Instead of sushi, how did I type it? Okay, let's go with the apple pie. There we go. If I execute it, different, right? Especially when you put this and this, right? Because sushi and apple pie are different from each other. Okay. Is it going to be different for Catalyst for what was the last name? Potato salad. There we go. If I run it, totally different result. Depending on what. Why is it scattered? Why is it not the same? Depending on what? All of this, I'm taking it depending on what? Red and blue, but why red and blue? Why 0 have, let's say this was potato salad, the last one, 3 blues, 3 reds. In here it is only 2 reds while the other are first of all, we only have in here 0 and 1. We already have only zeros and 1. And depending on how many, right and top, how many we actually have zeros, how many we have ones, depending on Midwestern or not Midwestern. Makes sense? Easy, correct? Good. Because with this, we are actually moving on to, there we go, to attribution selection with the information gain. Now this we have already talked about, but again, these data sets include descriptions of hypothetical samples corresponding to 23 species of gilled mushrooms in the Agaricus and Pipodia family. Okay. The example I gave is a little bit much more easier to go ahead and run, but just make sure with this is how we actually go ahead to the selection. Depending on the attribute name, what is it that we are looking for? Odors? No, we are looking for the gill color. Are we looking for the store crude? And you see each one of them has different multiple values that comes with them. So we actually go ahead and select one of those depending on what do we actually need from them. No, do we need it, let's say like white? Or no, we don't care about the color, we actually care about, let's say, the bruises. Does it actually have a bruise or not? Yes or no, 0 or 1. This is in here, you are going to see it is the chart for the entire mushroom database, and you see it is all of it is actually filled. From here, you are going to be seeing, depending on what do we actually have, depending on the gill color, whose value are actually coded as yellow, purple, brown, and so on. And each one of them, they are colored. Again, you can also see that the gill color actually reduces the entropy somewhat. This entropy and this entropy do fill the same exact space. All of it? No, it is actually reduced. So basically this part is actually the reduced. And in here, you're also going to see that many of the values such as the almond, the musty, for those entropy partitions, only in no odors has considerable entropy, which is about 20%. How can we see this? We can actually see it from here and here, depending on what you are actually selecting. Okay, with this, now, multivariate supervised segmentation, which is, again, if we select a single variable that gives the most information gain, we create a very simple segmentation. And it is correct. How many of you will go ahead to Amazon to buy, let's say, a notebook? Notebook. Not from Amazon, correct? So, but if I go ahead and take that, only from this particular information with a notebook, I will say that no one buys from Amazon. All the people that buys from Amazon are very low.
Yes.
But at the same time, if we select multiple attributes, each giving some information gain, how do we put them together? How many of you go to Amazon to buy notebook, book, coloring papers, coloring pens? What do you also buy from Amazon?
Cooking equipment.
Hmm? Cooking appliances, cooking books, cooking something. We actually go ahead and make it a little bit more clothes,
Yes.
doors. Someone tried to buy an infant, they were not able to. So, what do we actually go ahead and say for that? How can we actually make sure that everything is actually connected to it? We are actually using all that information. How are we going to make it up and running? That will work for us. This is an example. Celery is color coded from low, which is either blue or green, depending on how there it is, to high, yellow or red. What do you see in there? How many blues, how many greens, how many yellow, how many red? But at the same time, you see there are oranges, there are purples in there. How could you stratify it?
Like cluster.
Oh, not cluster, but how are you going to specify, stratify this one? If you want it to be stratified. That's where, look at it in here. When we see something like that, we look at the hits, we look at the years. where are the years starting from? From 0 up until, let's say, 25, right? From the hits from 0 up until, let's say, 200 or 300, right? Or in this case, it is 250. So, basically, you can go ahead depending on which one. In here, in this particular example, it went with the years, and you are going to see years less than 4.5, less than 4 years and a half. How many hits do they actually have? If the hits was actually less than 117.5, we actually go ahead and need to specify it a little bit more. But if we actually get 5.11 for the hits, we are already good to go. Now, if the hits in here, again, if it is less than 117, we also go ahead with a different not decision, but a different information. Either we get a 6 or a 6.74, right? Where does all this information actually come from? Because it is actually coming in. If we are actually keeping with the tree analogy, again, all of what we are trying to do is decision tree. So, the regions R1, R2, R3 are known as the terminal nodes, which in this particular case, they are here, here, and here. Okay. Another, the decision trees are typically drawn upside down. We never draw it from top. We always start from the end and then move forward. In the sense that the leaves are at the bottom of the tree. A nice example that was once given is, if you are going to go ahead and start, let's say, a new business, I'm going to make it a little bit more easier, let's say a new course, a new certificate. What are you going to do? Let's say it is a certificate for data science. Where do we start? No idea? The question is, you are tasked with building or creating everything for a data science certificate. Where are you going to start?
Maybe you research where to take the course or something.
You research, sorry, what?
You research where to take the course.
Where to detect the course?
Where to take the course, like you said.
Where to take the course? We already know that. If you are, let's say, Bo Valley is the one who asked you to do it. Where are you going to start from? You actually start with the very top, very beginning of it. You go ahead and search what is it that people who are going to hire data scientists are looking for, right? What do they need to know? They need to know, let's say, Python. They need to know data analysis. They need to know what else? Mathematics, statistics, probability, SQL, okay. Secret can also work. So, if you take those, data project management, can you take all of those and start them from the very first term where students go ahead and start? No. This is what they have finished. Okay, so we start with the most complicated, like the last term. What does students go ahead and need to finish? They need to finish their capstones. They need to finish their data analysis. They need to make sure if there is two math courses, the second course needs to be finished. This way, we have already done the second term or fourth term. What comes for the first term? How do we start that? If they have already finished what are the courses that needs to be done or finished, and the students needs to be finished successfully by them in order for them to take their capstones. What about statistics? What about programming language? Right? What about mathematics? Math, right? Will you be able to finish all of those and take your capstone at the same time? No. So we moved it step by step. That's why decision trees are actually upside down, because the end result is that apple. But for the apple to be actually come into fruition for it, it needs to be watered, it needs to be looked after, it needs to be, what else with the apple? Screens, I do believe, like looked after very well. Now, with that, that's where the points along the tree where the predictor space is split and referred to as internal nodes. And usually with the hitters trees, the two internal nodes are actually indicated by the text tiers less and the hits that is less than 20, 30. And this is basically what do we actually go ahead with. What do you see here? Now, look at this one in here, because I'm going to bring it this way. This is the structure for the tree. And do you see? It is upside down. So, basically we ask, that person is employed or not? If they are employed, okay, go ahead, not write off. You are not going to write off. They are employed. We are going to look for something else. Where they are employed, what they are what they are working with, but at the same time, if they are not employed, we are going to look for the balance. Now, when we go ahead and look for the balance, this is what we call the interior nodes, because balance is actually a node from the employed, but at the same time, it is the parent for the age. Now, with the balance, do they have the balance? Is it less than or equal to 50K, or is it greater than 50K? If it is less than 50K, go ahead, write it off. That means, depending on, in this particular example, can they go ahead and buy a home or not? Can they pay the mortgage for that or not? Simple. But if it is actually greater, less than or equal to 50K, then we are looking there for the age. How old are they? Are they seniors? Are they, let's say, still employed? Like, can someone go ahead and buy a mortgage or get a mortgage if they are 60 years old? They can. If they are working, they are going to look at it. But there, where is the age going to come? Because if the age, it is 5 years for their employment, 10 years for still for their employment, are they going to be greater or less than 45? How long are they going to work? Because if they are 60 or if they are 63, there is a huge difference between it. But if they are 50 or 40, there is also a huge difference in there. That's why we go ahead with the classes write off or not write off. Now with this, I'm going to come back in here with this. Depending on that, the overall, the tree stratifies or segments the players into 3 regions. What do you see? Depending on those regions. Region 1, those keys are actually, if they are less than 4.5, right? Which is 1. Everything in here. Here, we are actually looking for greater than 4.5, but at the same time, how many hits? Exactly. If it is less than 117.5, which is going to be this one in here, if it is greater than or equal to 17.5. Basic. Now, why do we need trees? Because decision trees, or you're going to see it as DT, but mostly people just name it as decision trees or classification trees. They are popular data mining tool. They are easy to understand, easy to implement, easy to use, computationally cheap. Think of that data that I have just showed you. Like I said, if it was 500 rows of data, how easy is it to actually go ahead and do it by hand? Not easy, but on the computer, how long did it actually take? The computer did not go ahead, like the answer was immediately displayed for me, right? It only took milliseconds. Almost all data mining packages include decision trees. They have advantages for model comprehensibility, which is important for model evaluation depending on what you need, and the communication to non-DM savvy stakeholders. If you go ahead and take this one, not this one, to a stakeholder, how good are they with understanding it? No, right? Like they are going to see, okay, that's very nice, there is a lot of pictures in there, a lot of colors. Explain it to us, right? And you will need to explain all of that. What does it mean? How does it work for them? So basically in here, it will just make it a little bit more easier. Now, predicting write-off of new customers. Classify Jane Doe, like you see in here. That's Jane Doe. The balance is 115K. That's what they have. Do we write it off or not? Employed? Do we write it off or not? Age 40. Do we write it off or not?
We'll write it off.
Why write it off?
Not right off.
Not write off.
Not
Even the, not, yes, we, not here. We are going here. They are employed. Yes, go ahead and find where he is employed. He is not employed, that means go find the balance. We already know that the balance is 115, so it is greater than 50K. We go ahead into this class and we ask, that 115, is it because they are transitioning between jobs or not? Do they have application to a different job when they are going to start? We go ahead with that. The age, we already know that it is 14, so basically we go ahead and ask, that 14, is it less or greater? Because at 40, who's going to be retired at 40? Too much, let's say, less people actually go ahead and retire at 40. They say, no, if I go ahead and keep working for 10 more years or 15 more years, my retirement is going to be better, right? So the chance of them being, or that gender being retired at that time is less. Are they transitioning between works? That means that this month he might not be able to pay it, but next month he will be. That's what we actually go ahead and do. That's why it is the tree structure. And of course there is rules for it. So, and I like these rules because it is easy to remember. There is no loops in there. No two parents share descendants. It's either yes or no. The age, can I connect for any reason the age with the balance? It cannot be connected. So basically, no two parents share descendants. There are no cycles. Today, the balance is less than 45. Tomorrow it is greater than 150. Does it work? Can I go ahead in circle for this? No. So, no cycles. The branches always point down. Nothing. No cycle, that means nothing is going back, nothing like a flow chart. So basically everything, it is always down, down, down. Every example always ends up at a leaf node with some specific class determination. It's either yes or no. Either yes, they have the age is less than 45 or greater than 45. There is no in between for them. And you are going to see that in everything. Less than or equal or greater than and equal, depending on what you are building for. Probability estimation trees, regression trees, we are going to go ahead and run with those. And this is a visualization segmentation. Now this visualization is very easy, right? How hard is it to actually go ahead and look for? Balance started. The balance, we actually have the age. And with the age, it is either greater than 50, less than or equal to 50. With the age, greater than 50, but that greater than 50, it is either go ahead less than 50 is less than 50, or less than or equal to 50, greater than 50. What is the probability for it? 12, 2.2 divided by 3, 2/3. So I have that decision made for me. When I'm actually going, I'm going with knowing exactly what I need for it. Okay, with all of this, there is also, if I come in here, decision lines. Decision surfaces and or decision boundaries refer to lines separating the regions. How many regions do I actually have?
4.
4, depending on what?
The balance and age.
The balance and the age. And as you can see, the balance is less than 50 and age is greater than or equal to 50. But in here, the balance is less than 50 and the age is actually also less than 50. So basically, I'm actually just going with all the probabilities that I have, and that is where the Dunn hyperplane refers to the general separating surface, whatever it may be. Because right now it is something like that, later on it might be something a little bit more different. But depending on those lines, and this is where you are going to see, do you see these particular pluses and dots? This, I'm going to bring it like this. Is it different? It's not different. It is just depending on what is it that I'm going to look for. So if you see that pattern, and here, this is for life insurance. Anyone that is a dot, a green dot, did not buy life insurance. Anyone that is a plus, they actually went ahead and bought life insurance. The pattern is, if balance is less than or equal to 50K and the age is greater than 45, that means it is a definite default. No, else it is a yes. Everyone got it, correct? And the split over age, you are going to see 50K here, split over age, that is 45. I actually got it from here. Good? Because I'm not done yet. What if the alternatives are there no partitioning this way? That means true boundary may not be closely approximated to the linear boundary. How is it going to be? In here, they definitely voted. Those, they did not. Here, some of them voted, most of them they did not. Correct? I'm not done yet. Because this, let's do it here. The set of rules. If those people are actually employed, then class, no, we are going to write them off. If they are employed and the balance is less than 50K, then the class is no, again, we are writing them off. If they are employed or not employed and the balance is greater than 50K and the age is less than 50, then the class is no. Go ahead, write it off. If the employed is equal to no and the balance is greater than or equal to 50K and the age is greater than or equal to 50, then the class, again, write it off. Okay. What do you see? How many for this? Are they interested in life insurance or no? No. What do we look for? We are not guessing in here. We are just asking income, less or greater. No? Then, if it is a yes, what is the age? If it is the age, depending on 45, less or greater? Greater or less?
Interested.
Less, it is a yes.
Less, say no.
It is less than or equal to 45, it is a yes. But if it is greater than 45, do they buy it? No. So, this one in here, it is a no. Quite easy, right?
Mm.
So, basically, depending on this, what if we go ahead and have it using the program? What is the probability of them buying that life insurance? If the probability in there is 3 divided by 7, do you think they are going to buy it or no? If the probability in here is 3 divided by 7, do you think they are going to buy it or not? Buy the life insurance or not? Will it be a dot, a green dot, did not buy it, or a plus, they are interested in buying, or they have bought it? 0.43.
Some will buy.
It is not 50. It is not 0.7 or 0.5.
0.45.
Yes. Will they go ahead with buy it or no?
They are less likely to buy.
Less likely to buy it. Exactly. They might not buy it because it is less than what they need. Make sense?
Yeah.
Easy, correct? Any questions? No?
Can you go back to the stratifying slide?
This one.
The previous one. The base also.
This one.
The next one.
This one? Okay.
Do we decide the big point 4.5 or?
4.5 for the years?
Yeah, and hits.
Okay. What do you see?
How do we decide?
Okay. How do you see it? If you look at this chart in there, what do you see?
They're more crowded?
They are actually more crowded in this section, right? Like in here, do you see? Because I mentioned purple. How do you get purple? What is the colors that are actually you should have? 4 colors, right? That is blue, green, yellow, and red. In here, you have got green. You have, let's say, dark green and light green. So that actually means there is a little bit of overlap So if I just take it like between 15 and 20 years, how do I go ahead with this? Will I get the information that I need?
To me here, it is more homogeneous.
In here,
It is more.
this particular part, not even, if you see it is not even 5, it is less than 5. So basically, this particular one, it is a lot of, let's say, dots that are actually overlapping with each
Yeah,
other.
that's the reason for the change of
But
color.
do we have any formula to decide, like, is this at 4.5 or instead of 5?
That is actually going to be depending on how you are going to do your decision tree. That particular one is going to bring us in here, in this part, 2 questions. If we select the multiple attributes, each giving us information key, how do we put them together? If you have a lot, like the Amazon example, if you have a lot, most people you are going to say, okay, they go ahead with plants, they go ahead with stationery, they go ahead with, let's say, building materials. How does those 3 connect to each other? What is the connection? At the same time, if you only take, let's say, plants, for example, if you just say, okay, people go ahead and buy plants, what happened to the other kind of people? To the stationery, what happened to the people who go ahead and buy building materials? Too less information, too bad, too long information. So in there and in Amazon, you can just go ahead a little bit more generic with it and say, like with the elephant, they were not able to go ahead and buy it because Amazon doesn't sell elephants. Make sense?
Is it kind of trial and error?
Trial and error, and we go ahead with more on statistics. That's where statistics go. How much do we actually go ahead and run with it?
Actually, if I'm given a data set in another category, I don't know how to start.
That usually when they go ahead, okay, I can do it this way. You see this particular data, okay? It is vegetarian, restaurant visits, spicy, affected. Okay? With the target. Now the target is yes and the ID, but that yes and that no, depending on what? Depending on how many restaurant visits they actually went ahead with. If you are actually going to see, I'm going to take this one, number 16. Vegetarian, yes, 2. They are restaurant visits 3 times. The affinity is actually 1. What do you see there? But the target is no. So how did I take that target?
Because of the slight affinity, this one.
Depending on what? Depending on the vegetarian, because even though the vegetarian it is only 1 and 2. If you look at it, there is no 3. But if you look for the restaurant visits, it is either they visited or they did not visit. But instead of me doing it 0, 1, it was done at 0, 3. While spice affinity, what do you see? It was actually 3 numbers, 1, 2, 3. Depending on that, I made sure that the decision I'm going to get, the targeted decision I'm going to get, yes, in this one, they went ahead to the restaurant, they are, in this particular example, they are not vegetarians. They visited the restaurant, the spice affinity is actually low, then the target is actually low. Well, if you go ahead and take, I do believe, one that is this one. Yes. Do you see here? What is it? Are they vegetarians? No. What, how many do they? They visited. What is the spice affinity for them. Two, not three, just in between 1 and 2. So what is the target? It is a no. If we go ahead and take yes, let's see, what do we have for yes? Okay, we can go ahead with this. Are they vegetarians?
Yes.
Yes or no? How many times do they actually visit? They visited. Let's say 3 is actually visited. Spice affinity, too much in there. So, what is the probability of them going into the restaurant? High. So, the target is yes. So basically, when we are creating it, we are creating it depending on information that we already have. Because when you go ahead with the decision tree, you run the decision tree not for 15 lines of, let's say, of data. You run it from a lot of data, and from there you are able to see the same that is happening in here. In here. This one, if we are going to take it as an example, we can say in here it took, let's say, around 25. In here, it is around a little bit more, 30. But in here, it is, especially in this particular place, it is around 100. So, which ones do we actually go with the 100? A little bit more people follow that information. That's why in this particular example for the, or maybe this one will make it a little bit more. Actually, no, this one will make it a little bit more easier. Even with this, do you see how it was actually cut? 4.5 years, but after that, between 4.5 years and 24. How did we actually cut it? We cut it depending on the age. The age is very important in with the baseball, with the basketball. I do believe like the very first few years, they are able to do a little bit more hits because they are a little bit more energetic. But if you take a person that is, let's say 50 or 60, will they be able to score the same as if they are actually 25? No.
So it depends on the nature
Yeah.
of the data,
Mhm.
and it depends on the density of the data.
Exactly. Another thing is you can also look at it from here, because this is the same chart. Nothing changed. But what do you see? If the balance and the age, if the age is actually greater than 50 or equal to 50, how many people actually went ahead and voted? How many people did not buy it? 2. You can see here 2 did not buy it. Why? Only 1 voted. That's also, we take it into consideration. That's why it is called decision tree, because in there we actually go 1, 2, 3, 4, and it goes as a tree. Questions? Questions?
The number of segments are dependable on how, like, needs, right?
Yes. Yes. If it is not like specified, yes. What does it actually mean? That moves forward. Okay. Now with this, do we have the time? Okay, we don't have the time for this, so I will go ahead and ask you, this is something that you will need to go ahead and finish for next class. There is one command. Apparently from the college it is actually not allowing us to go ahead and run it. This one. There. Okay. There. Run this particular command. Most probably at home. It will take, because in here you are just going to make sure that you are actually installing the package to make the graphs actually display it for you so that we can run it for next class. I have tried it in here in the college. For some reason it is not running, but at home it took me around 2 or 3 minutes to go ahead and make sure that everything has been installed. The reason for this, most probably the API is not allowing it. Okay, with this then we are going to go ahead with the decisions trees for the file and how to write the code for it and display it. Other than this, if there is no other question or no questions, then have a nice rest of the day and see you all on Thursday. Yes?
Well done.
I have a question regarding quizzes. So,